Hey guys, and welcome back. My name is Miss Danielson, and this is our third lesson on solving simultaneous equations. I hope you joined us for our previous two lessons, particularly our first lesson, our introduction to simultaneous equations, where we were looking at equations with the same coefficients for one of the variables. If you missed those lessons, I'm linking them down in the description box for you below, so you can check those out before we carry on. But today we're going to be looking at simultaneous equations where the coefficients may seem to match, but they've got the opposite positive or negative signs. In order to grasp this topic well, you must also have a pretty good understanding of adding and subtracting integer values, so I'll link that lesson down below as well. But what I mean by integer values is positive or negative values. So here's an example I've got to the side where I've dug out some amount of dirt. So I'm using D to represent the amount of dirt that I've dug out of this hole. So in this hole, I'm missing D amount of dirt. So I've got minus D in this hole. But the dirt that I've taken from this hole is piled up over here to the side. So here I've got positive D dirt. Now, if I were to add these two amounts of dirt together, so minus D plus positive D, what would I have? Well, I would have filled in that hole. I would be left with no hole, but also no pile of dirt. I'm back to where I began with 0. Now, this is how we're going to manage to eliminate one of our variables so that we can solve simultaneous equations. If you're with us for our previous lessons, you'll understand what I mean already. If not, check out our previous lessons, and then let's get on to today's lesson. Remember in our first two lessons, I outlined the steps for solving simultaneous equations, but they change a little bit depending on the situation. The first step is always the same, however. We label our equations, equation number 1 and equation number 2. Step 2, if both the equations have the same number of x's or y's, as we did in the first lesson, but here the signs are opposite, so one's positive and one's negative, we're going to eliminate one of the variables, either the x variable or the y variable, by adding the two equations together. Remember in our introductory lesson, we were subtracting the equations from each other. Step 4, we're going to solve the remaining equation by finding the single unknown variable. And step 5, not really a step of working, but recognize that we have half of our answer. So write that answer out, put a box around it so it's nice and clear and easy to follow, and move on to step 6. Step 6, we're going to substitute the value we've found into either of the equations. You can choose which one you think will be easier, and we'll solve that equation to find the value of the other unknown variable. Once you've got both variable values, we go on to step 7. Don't skip it out. We always check our answers. We always check our answers. And if you used equation 1 in step 6, we'll use equation 2 to do this. If you used equation 2 in step 6, we use equation 1 to do this. Let's get on to an example so you can see the difference between these types of simultaneous equations problems and the ones we've seen in lesson 1 and lesson 2. So here I've got a set of equations where I've got two unknown variables. I don't know what x is and I don't know what y is, but the x and y values must follow these two rules. 2 times the x value plus 4 times the y value must be equal to -8. And -3 times the x value minus 4 times the y value must be equal to 6. So let's go through these steps again. Step 1, let's label our equations 1 and 2. Now, I've been typing this for you, but when you label your equations, you should be labeling them with the number 1, and let's put a circle around it so you can clearly see that that is not part of the equation. That is just labeling that this is equation number 1. And this is my equation number 2. I'll put a 2, and I'll put a circle around it to make it really clear that this is just equation number 2. It's not 2 minus 3x. Okay, step 2. If both equations have the same number of x's or y's, but the signs are opposite. Now, is that the case here? I certainly don't have the same number of x's, 2x, and negative 3x's, they're not the same. But look at the coefficients for the y terms. Here I've got positive 4y, and here I've got negative 4y. They're almost the same coefficients, but the signs are opposite. So yes, step 2, I do have the same number of y's, but the signs are opposite. So let's go on to step 3. Eliminate one of the variables, either the x or the y variable, by adding the two equations together. When I add these two equations together, positive 4y plus negative 4y will eliminate my y's. So let's go ahead and add equation 1 and 2 together. Again, I'll label my working, so I've got equation 1 plus equation 2. Again, if you're handwriting this, that will be a 1 with a circle around it, plus a 2 with a circle around it, and next to that we'll have our answers. We're going to do 2x plus negative 3x. When you add like terms together, we add the coefficients. So positive 2 plus minus 3. And what's 2 plus minus 3? You should know from adding integer values that adding a negative is the same thing as subtracting. So that's 2 minus 3, which is negative 1. Then we're going to look at our y terms and pay attention to the signs. So positive 4 plus negative 4y, so minus 4. Remember, adding a negative is the same thing as subtracting. So we're doing 4 minus 4, that's 0. That's how we eliminate the y term. And then we'll go on to look at the numbers on the right-hand side of this equation. So negative 8, and I'm adding positive 6. Negative 8 plus 6, that's negative 2. So showing this vertically, this will be negative 1x, and the y's have disappeared, so no y's, is equal to negative 2. Step 4, we're going to solve the remaining equation to find the single unknown value. That is, find the value of the x. So let's get the x on its own. Right now it's being multiplied by this negative 1. So the opposite of multiplying by negative 1 will divide by negative 1. Now I very often write this as negative 2. Dividing by negative 1, I'll write that over negative 1. And you should hopefully be able to work that out easily. Negative divided by negative is going to be positive, so that's x equals 2. We've got our answer for x now. Let's put a box around it. In fact, that's our step number 5. Once we know the value of one of our variables, we put a box around it, and we're halfway there. Step 6, let's substitute the answer we found into either of the equations to find the other unknown variable. So either into equation 1 or equation 2. In this case, I'm going to substitute into equation 1, and I always remember to label my equation. So equation 1, if I substitute x equals 2 into it, I've got 2x, that's 2 2's because I've just worked out that x is equal to 2, plus 4y equals negative 8. Working this through, 2 times 2, that's 4, so 4 plus 4y is equal to negative 8. Getting the y on its own, opposite of adding 4 is subtracting 4. So this 4, which was added, has come over here to be subtracted. Let's simplify that. Negative 8 minus 4, that's negative 12. We're just working downwards. So 4y is equal to negative 12. The opposite of multiplying by 4 is dividing by 4. So y is equal to negative 12 divided by 4. Or as I like to write it, negative 12 divided by 4. And that works out to be negative 3. So I've got my answer for y as well. I can put a box around that. Y is equal to negative 3. So I've got my two answers. X is equal to 2 and y is equal to negative 3. I want to say I'm finished, but remember there is step 7. We should always check our answers. So to check this equation, we already used equation 1 to find y. So now let's use the second equation. Negative 3 times the x value minus 4 times the y value should make 6. So writing that second equation out again. Remember, I want you to label your working, so I've put a 2 and I've circled it. This is equation 2, but I already know that x is equal to 2 and that y is equal to -3. So we'll substitute those values in using brackets. -3 times 2 minus 4 times -3 should be equal to 6. Is that true? Let's work it out. -3 times 2 is -6, and -4 times -3, watch out, that's a double negative, that's going to become positive, is positive 12. Is -6 plus 12 equal to 6? Yes, it is. And remember, we know that our answer is right when the left side of our equation works out to be equal to the right side of our equation. But don't confuse this with our answer. 6 is not our answer. Our answer is in the box above. X is equal to 2 and y is equal to -3. Take a moment now, if you need to go back over that example and have another look through the 7 steps that we followed before we go on to the practice exercise. Here you've got 12 questions that I need you to work out, but pay close attention to the positive or negative signs, because some of these questions would require you to add your equations together to eliminate one of the variables, and some of these equations would require you to subtract the equations from each other, as we did in our introductory lesson. Can you label each of these questions to tell me whether you would add or subtract? Hit pause and take a minute to do that now, and then I'll give you a bit of a hint before we go over the answers. I hope you had a chance to hit pause, because you should have already worked out that you're going to add all of the equations in the first row, because as you see, I've got a positive and negative y. It's the same number of y's, but the signs are opposite. I could add equation 2 as well, because I've got the same number of y's, but one's positive and one's negative. However, you might have also noticed that the x's are exactly the same, so you could have actually subtracted these. For question 3, we've got the same number of y's, 3 y's and 3 y's, but we've got opposite signs, so again we'll add. And for question 4, we've got the same number of y's, but one's positive and one's negative, so again we'll add. If you haven't yet decided whether you will add or subtract for the rest of these questions, make sure you hit pause and do that now. For the second row, there are some subtractions here. Question 5 I will add because I've got the same number of y's, but one's positive or negative. But question 6, I've got exactly the same number of y's. Both of them are positive 2y, so I'll subtract those. For question 7, I've got the same number of x's exactly, so I'll subtract those. And for question 8, again, I've got exactly the same number of y's, so I'll subtract those. If you needed that as a hint before you labeled all of your equations with either add or subtract, make sure you hit pause now and you do that last row on your own. We're going to subtract the equations in question 9 to eliminate those x's. We're going to add the equations in question 10 to eliminate those x's. In question 11, we're going to add those equations to eliminate the x's. And in question 12, again, we're going to add, but to eliminate the y's. Now that you know how you're going to solve these simultaneous equations, go ahead and hit pause, copy them out. Don't forget to label them, equation 1 and equation 2. Show all your working, including your check, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come our answers. For question 1, you eliminated those y's and you found the x first. For question 2, you may have eliminated the x's by subtracting and found the y first, or eliminated the y's by adding and found the x first. For question 3, we added to eliminate the y's. For question 4, we added to eliminate the y's. For question 5, we added to eliminate the y's. And notice I gave my answer in fraction form. For x, As it's a half, we know that that's 0.5, and that's fine as a decimal. But for y, it's -1 divided by 3. I'd rather write that as -1/3 than -0.3 recurring, because -1/3 is perfectly accurate. If you wrote -0.3 recurring, that's perfectly fine. However, if we want to do the check with that value, it won't be perfectly accurate if you just substitute in -0.3. For question 6, we subtracted to eliminate the y's. For question 7, we subtracted to eliminate the x's. For question 8, we subtracted to eliminate the y's. For question 9, we subtracted to eliminate the x's. For question 10, we added to eliminate the x's. For question 11, we added to eliminate the x's. And for question 12, we added to eliminate the y's. Now, how did that go? Once again, if you've done your checks, there should be no surprises here, but please let me know if anybody had any trouble with question 5. We need to get used to working with fractions rather than decimals, particularly when we've got recurring decimal answers or decimal answers that are simply very long and you need to round in order to write them down. So as this is our last lesson on simultaneous equation, you should now be able to solve any kind of simultaneous equation, whether you've got the same number of some variable, or you've got the same number of some variable, but one is positive and one is negative. And remember lesson 2, we can even solve simultaneous equations when the coefficients of both variables are different. We do that by multiplication. So remember in our first lesson where we skipped out these 3 questions because we didn't have the same number of x's or the same number of y's? Well, now you have the tools to be able to do that. So go ahead and challenge yourself to see if you can answer these 3 questions now. Let me know down in the comment section if you figured out your answers. As an added bonus question, I wonder who could solve this set of simultaneous equations. Don't spend too long on it because I'll tell you right now, it can't be solved. So what I really want to know is who can tell me why this set of simultaneous equations cannot be solved. Let me know down in the comment section if you can figure it out. This has been our last lesson on solving simultaneous equations, so I hope you've enjoyed it and learned a lot. Please let me know if you still have any doubts or if you come across any questions that you're struggling with so I can help you out with those. Otherwise, keep up the good work, keep practicing, and I'll see you soon with our next topic.